Welcome to 10.3 Circles and Spheres. Complete the problems with me on your own and pause the video often. Here are the topics and key skills and understanding, the grades, vocabulary, and concepts. So what are circles and spheres? To the eye, these are distinguished by their perfect roundness, but informally we might say that a sphere is the surface of a ball, and this describes circles and spheres from an informal or artistic point of view, but there's also a mathematical point of view. So let's start with circles. A circle has a center, a radius, and a diameter. So a circle is the collection of all points in a plane that are a certain fixed distance from the center, from a certain fixed point in the plane. So the fixed point is the center. So we've got a center of our circle. And the fixed distance is called the radius, or if you've got, there are radii all over the circle, infinitely many radii. These are all radii, all of them, because they go from the center to the edge of the circle. Now, a diameter is the distance from one edge to the other edge, but it must go through the center. And there are many, infinitely many diameters, as long as it goes from edge to edge, but goes through the center. This would be a diameter. Let's look at a sphere. A sphere is almost the same, but it's just in space rather than on a plane. So a sphere is the collection of all points in space that are a certain fixed distance away from a certain fixed point in space, and that fixed point is called the center. And the distance is called the radius of the sphere. So the radius is the distance from the center to any point on the sphere. And the diameter is 2 times the radius, just like with the circle. It's the distance all the way across, but through the center. Let's look at an example here. What is the same about the two circles? What is different? All right, so let's first just look at the circles. So first of all, we see that this point goes through the center from edge to edge. So this is a diameter. So we can see that this one has a diameter of 8. Well, we know that we have a diameter, but we don't know what its length is. But what they do tell us is we do see that we have a radius here. Now, what do we know about radii and diameter is that the diameter is twice of a radius. So if this is a radius of 4, then the diameter, right, would be another 4, which would be 8. So they have the same radius and diameter. The only difference is, let's see here, there's additional radii, right? This graph, this circle has more radii drawn, but that's the only difference. So what is the length of segment AD? So let's find segment AD. So that's this segment right here. Now this segment goes from the edge of the circle to the center. So this is a radius. And so it is 4 centimeters because it is a radius. On the first circle, what segment is the diameter and how long is it? So we are going from edge to edge through the center. So that would be segment EB or BE, and it is 8 centimeters because a diameter is twice a radius. Here it is written out, if that helps you. Let's do one more together here. A circle is inscribed in a square, which means that it's perfectly in it, edge to edge. Determine the radius of the circle if the area of the square is 36 square units. Well, what do we know about squares? We know that they have the same side lengths, and that to get the area, we would do side length times side length. And we know that the side length is 36. So what times what gives us 36? 6. So we know that this length here, I'll use a different color because that's blue, is 6. And this length here is 6. So if we know that this whole length is 6, well, then we know that this whole length is also 6. And what is this? This is the diameter. We know that the diameter is 6. But they want the radius. Well, what's the radius? Half of the diameter. The radius will be 3. And so the radius of this circle is 3. Go ahead and give this problem a try. Press play when you're ready to see the solution. And there we go. A compass is a great way to draw a almost perfect circle. So that is a very specific tool, and you kind of, wherever you place that sharp pointy is your center, and then the pencil, and you can kind of change this distance to make a larger or smaller radius. Once you have your circle, whatever, and then if you want to draw a sphere, you kind of do the best you can, and then you just like follow it up there. And this is not perfect, but it's definitely good enough for what we're doing here. And you can make a compass at home with a paper clip. The only problem with this is that the paper clip is your radius. So if you want something that is not a paper clip distance, you can use 2 pencils with a string. And you're probably going to have to make some circles at home. So I do recommend maybe making a homemade compass, but you can be the decider of that. So how do circles meet? Circles can meet in 3 possible arrangements. They either don't meet, they meet at a single point, or they meet at 2 points. Spheres, on the other hand, they either don't meet, they meet at a single point, or those 2 points are actually creating a circle. So let's take a look at this example. Smallville is 7 miles south of Gotham. Will is 8 miles from Gotham and 6 miles from Smallville. Draw a map showing where Will could be. Be sure to show a scale for your map. Explain why you draw your map the way you do. Can you pinpoint Will to one location? All right, so Gotham. All right, let's see here. Now, Smallville is 7 miles south. So let's see here. Let's do 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7 miles to Smallville. Now, Will is 8 miles from Gotham. All right, so now this is 7. So that's 2, or that's 1, excuse me. This would be 2, 4, 6, that would be 8. Okay, so if Will is 8 miles from Gotham, Will's 8 miles from Gotham, then Will is 1, 2, 3, 4, 5, 6, 7, 8. He could be anywhere along, and I should 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So Will is going to be along this kind of circle that I'm attempting to draw here. So Will is 8 miles from Gotham and 6 miles from Smallville. So here's Smallville. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's looking like Will is this distance, and again, that's not perfect, from Smallville. So where is Will? Let's see. Where is Will? Well, Will could be here at that intersection point, or Will could be there. Because if he's there or there, he is both 6 miles from Smallville and 8 miles from Gotham. So this is 1 mile. That's my key, or my scale. Can you pinpoint Will to one location? No, the circles meet at 2 spots. And here is a beautiful image of it with actual beautiful circles. Let's do one more example together, and then you'll do one on your own. A new mall is to be built to serve towns of Sunnyvale and Gloomington, whose centers are 6 miles apart. Okay, so we've got Sunnyvale, 1, 2, 3, 4, 5, 6, and Gloomington. The developers want to locate the mall that is not more than 3 miles from the center of Sunnyvale. Okay, so 3 miles. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Terrible, but you get the idea. And not more than 5 miles from the center of Gloomville. Okay, so 5 miles. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, draw a simple map showing Sunnyvale, Gloomington, and all potential locations based on this given information. Well, the overlapping region is anywhere in this region here. So they could build a mall anywhere in this region here. And my scale is, that is 1 mile. And again, if you prefer a beautiful version and a little bit more, there you go. And you give these 3 problems a try. Press play when you're ready to see the solution. And that concludes section 10.3.